Alright, so today we're going to look at the volume of a cone. And before I introduce the volume of a cone and its formula, I want to show you how it's developed in relation to the volume of a cylinder, which we already did. So if you have a cylinder, and the cylinder is this, well, it has a radius of 2 and a height of 5, and you imagine the cone that sits perfectly within that cylinder, that cone would also have a height of 5, and the base would be a circle with the radius of 2. If I take this cone 3 times, it will be equal to the entire volume of the cylinder. So I'm going to show you a little bit of a visual, a demonstration that would actually display this. So we can now see that if you want just one cone, you are really only wanting a third of that cylinder. And if you want the volume for 2 cones, it's 2/3 of the cylinder up to here. And if you want all 3 cones, then it's the entire cylinder. So with that being said, the volume of a single cone, assuming that this would still be the height of 5, would be 1/3 the volume of the entire cylinder. And recall that the cylinder had a base of a circle, so therefore the pi r squared is the base times the height, that gives us our cylinder, and 1/3 of the cylinder would be this entire cone. So that's where the formula comes from, that's how it's developed. All right, so let's look at the volume of a cone now. And I'm going to give you the general formula of a cone. And it has a height, which goes straight to the center of the circle. And then it also has a radius or a diameter, depending on what's given to you. But in this case, we always need radius because that's going to help us in our calculation. And the bottom, that entire region, is what we would call the base, capital B. So the general rule would have been 1/3 of the base times height. Because remember, base times height alone would have been that entire cylinder that it would have fit into. But now since we only want the cone, not the entire cylinder, we do 1/3 of what that cylinder would have been. So volume equals 1/3. And we're thinking of that cylinder that it would have fit into. So the base would be that same circle, which we now know is the area of a circle, and the height, whichever the height of the cone is. So this is going to be the formula we use. Okay, and now let me show you what an example looks like using that formula. We're given a cone, and this cone has a height of 6 meters, and then we have a diameter of 4 meters. Okay, and we want to find the volume. Okay, now to find the volume, we're going to use the formula 1/3 the base, which we know is a circular shape, so it's pi r squared, times height. So the volume is going to equal 1/3. Now, I know that the diameter is given to me and it's 4. But in my formula, I have an r. So I need to make this into. So pi times 2 squared times 6. 6 being my height still. So now you're going to end up with volume equals, this would be 4 times 6, so that's 1/3. 4 times 6, I know that's 24. And then just to further make the calculation, since I'm not grabbing my calculator right now. Multiplying these two, a third of 24 is 8 pi. Now right now this is still considered an exact answer because I am encompassing all of the digits of pi when I use this symbol. But as soon as I start to plug in 3.14, it is now an approximation because 3.14 is not including all of the other decimals, but it is a pretty good estimate. So we'll say volume is approximately equal to, and 3.14 is equal to 25.1 meters cubed because we're referring to volume. And that is your answer for the volume of that cone. Now let's look at example 2. Example 2 is giving me the volume already, but we're told that we have to find the height. And this one is given on its side. Just a little bit of a different perspective. And again, it goes to the center of the cone to this height, the tallest point. So that's still going to be our h. And this time we are given the radius because it's halfway across, and they're saying that that's 9 feet. And it is perpendicular, right? And it says find the height when the volume is (956 feet squared. Cubed, sorry. All right. So again, we have our formula. And I'm not going to put capital B because I already know that it's a circle on the base. So I'm just going to go ahead and put in the formula for the circle area of that entire base times the height. Now we know the volume is 956, so I can go ahead and substitute 956 for the volume since that's given to me. 1/3 pi. The radius we do know is 9 squared times the height, which we do not know. Okay. And so it's going to be 956 equals 1/3 pi times 81h. And if we just put all of these together, 1/3 of 81 is 27. 956. I could have just punched this all in the calculator, but why not just keep calculating? And that is 84.78. So we're going to divide by 84.78. And you get 11.3, approximately equal to h, which is in feet. All right. Example 3 is asking, you have a timer. We'll just say it's about the timer. And sand falls at a rate of 50 millimeters per second. So it's going to be a timer that looks like two cones, one on top of the other. And the sand is falling from one cone into the other one. And in this cone, we have some sand. I'll just make it solid. And we're given some dimensions of that. So this is some yellow sand. And that sand is going to be trickling down into the other cylinder, the other cone. It's going to be trickling down into the other cone. And it says it trickles down at a rate of 50 millimeters cubed per second. How long before the time is up? Right, so we do know that when it's empty on the top, time's up. So we need to find out how much volume of sand we have originally. And they're telling us that the height of the sand, or the cone which is filled with sand, is going to be 24 millimeters. And the radius of this little circle here is 10 millimeters. Okay, so we want to know when all of this volume of yellow sand is gone, time's going to be up. So first we need to find out what is the volume of that quantity of sand. So it's in the shape of a cone right now, so we're going to try to find the volume of this little yellow cone. So the volume will be 1/3. This base would be considered the base here, is a circle with a radius of 10. So pi times 10 squared times the height of this little yellow sand cone, 24. Okay, and then from there we do 1/3 pi times 100 times 24. 10 times 10 is 100. And then you get volume equals, well, 1/3 of 124. That would be 800 pi. I'm just doing all the numbers first. 240, 1/3 of 240 is 800. I'm sorry, 2,400 is 800. And then when we divide, we multiply this, and you get approximately 2,513 millimeters cubed of sand. Okay, so that's how much sand has to trickle down into the other So 2,513 millimeters of sand has to trickle down into the other reservoir for the time to be up. So how fast is this happening? So we got 55 millimeters per second. So there's two methods you can do this. Some of you already know to go quick to division, and that's perfectly fine. So you just tell yourself, method 1. Well, I know I have 2,513 millimeters cubed. And you want to know if you divide it by 50 millimeters cubed, every 50 is 1 second. So you want to know how many seconds that would be. So you would just divide, and you would get 50.26 seconds. Okay, that's if you just instinctively know that this is a division problem. You want to know how many times does 50 milliliters fit into that amount, because you know that every 50 millimeters represents a second. However, if you weren't aware of that, method 2 would be the more exact, precise mathematical way of going about this. And that would mean you would set up a proportion. You know that 1 second will drop 50 millimeters cubed. We want to know how many seconds would it take to drop 2,513 millimeters cubed. So you just set up a proportion. And then you would cross multiply 50x, cross multiply 2,513. You end up with the same math, and you get your answer was 50.26 seconds. All right, so instinctively, if you really knew that you already had to just find how many 50 millimeters cubes fit into this amount, each one represents a second, you're good. Otherwise, you want to know you have 1 second. Every second it drops 50 millimeters cubed of sand. So you want to know how many seconds does it take to drop 2,513 millimeters of sand. And then when you set up your proportions, units are in the same representation, numerator, numerator, denominator, denominator, and you cross multiply and you can get your same answer. There you go.